Start. Hi, this is Dr. MSNA Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about preparation and properties of and applications of polyvinyl chloride. So, what is PVC? PVC is polyvinyl chloride. It is a versatile thermoplastic type of material which is obtained from ethylene and salt by vinyl chloride polymerization. So it is a type of versatile thermoplastic material which is formed by ethylene and salt by vinyl chloride polymerization. And it is a third most widely used material in the world after polythene and polypropylene. It is a third most type of thermoplastic material. And cost also very less. Cost of PVC is very less. And it is a chemical and biological resistant, and it is used in making sewage pipes and good hardness and mechanical properties, and poor heat stability, and melting point is 140 degrees centigrade. So that is about brief introduction about polyvinyl chloride. Next, coming to the history of polyvinyl chloride. So it was first discovered accidentally at least twice in the 19th century. First by French chemist Henri Victor Lignaud, and then 1872 by German chemist Eugen Baumann. In the early 20th century, the Russian chemist Ivan Astromishinsky and Fritz Latte of German chemical company, that is Grisham Electron, both attempt to use PVC in commercial products. But some difficulties came due to the rigidness. And later, Walden Seaman and B.F. Goodrich Company developed a method in 1926 to plasticize PVC by blending it with various additives. The result was a more flexible and more easily proceed material that soon achieved widespread commercial use. Next, type of PVC. Usually there are two types of PVC are available. That is, first one is rigid PVC and flexible PVC. So rigid PVC is a form of rigid, and it is used in construction as pipes, used on profile applications, that is doors and windows, and used for bottles and other non-food packages and cards. And next, coming to the flexible PVC, it is more flexible than rigid PVC by the addition of plasticizers. And flexible PVC is very soft and usually it is used in plumbing and electrical cable insulation, etc. So these are the key differences between the rigid PVC and flexible PVC. Next, coming to the preparation, how we can prepare PVC. Vinyl chloride is synthesized on commercial scale by following process. The earliest route to vinyl chloride was from acetylene and HCl. So this is a acetylene react with HCl, produce PVC. So it is a type of additional polymerization reaction. So we know that what is the additional polymerization and what is the condensation polymerization. The type of polymerization reaction in which there is no byproducts formation. So that is known as additional polymerization. So if you see the synthesis of PVC, here there is no byproduct. There is no byproduct. So that's why we can say that it is a type of additional polymerization. Hence, PVC is prepared by additional polymerization of acetylene and hydrogen chloride. So that is the difference between the addition and condensation polymerization reactions. And whereas in condensation polymerization reaction, some byproduct will be eliminated. And one more preparation method of PVC is from ethylene. So ethylene become more abundant and technology based on chlorination of ethylene dichloride. So this is ethylene react with chlorine, forms dichloroethylene. In first step, dichloroethylene has been formed. So that dichloroethylene is heating up to 500 degrees centigrade, forms PVC. So this is the second method of preparation of polyvinyl chloride. So in this reaction, first ethylene treated with chlorine forms dichloroethylene. That dichloroethylene is heating at 500 degrees centigrade, forms PVC. Forms vinyl chloride, that on polymerization gives PVC. Next, some other routes of preparation of PVC. So commercial polymerization of PVC is done by free radical catalyst employing bulk, suspension and emulsion techniques. Suspension and emulsion techniques are most commonly used in industries. About 80% of production involves suspension polymerization mechanism. Emulsion polymerization accounts for about 12% and bulk polymerization accounts for 8%. Let us see one by one. First, coming to the bulk polymerization. It is done in a rotating cylindrical reactor with tumbling steel balls inside the to facilitate removal of heat of polymerization from the monomer and polymer heterogeneous system. Peroxy dicarbonates are used as a initiators in a bulk and suspension polymerization reaction. Next, coming to the suspension and emulsion type of polymerization. So it is done in a sealed tank jacketed pressure vessels. For injection molding, extraction and for clear objects and for electrical insulation purpose, bulk and suspension grade PVC resin are used. Next, coming to the structure and properties of PVC. So first coming to the structure. So it is a linear type of polymer and it is a thermoplastic in nature. So linear polymer means here there is no sub branches. Polymer should be linear like CH2 double bond CH, Cl, CH2 double bond CH, Cl. So like that. Structure should be linear. Here there is no cross linkages in between the polymeric structure. And it is a thermoplastic. So here what is a thermoplastic and what is a thermosetting already we discussed or we know that. So thermoplastics means it can be simply remold. That means when you are heating the PVC, that PVC will become soft. At the same time, when you are cooling the PVC, that PVC will become hard. That is nothing but remolding tendency. The polymer can able to remold itself by either cooling or heating. That property is known as thermoplastic property. And it is a white brittle solid. Brittle means more hard. And rigid material with a characteristics of tendency to stick to metallic surfaces. It contains about 56.8% chlorine content. So PVC contains 56.5% of chlorine content. And it is insoluble in or hydrocarbon solvents. And there is a few solvent for PVC like cyclohexane and tetrahydrofuran. So in that particular solvents only PVC will be soluble in cyclohexane and tetrahydrofuran. And remaining all solvents PVC is not soluble. And PVC is the polymer as produced commercially is amorphous in nature. And coming to the melting point of PVC, 212 degrees Celsius. And TZ, gas transition temperature. So gas transition temperature of PVC is 80 degrees Celsius. Next, coming to the electrical properties of PVC. So it is a polymer with good insulation properties. That means it is act as a insulator. But in some cases, because of its higher polar nature, the electrical insulating property is inferior to non-polar polymers such as polyethylene and polypropylene. And it is generally suitable for medium or low voltage and low frequency insulation materials. And next coming to the thermal properties. The heat stability of PVC is very poor When the temperature reaches 140 degrees centigrade, PVC starts to decompose. Weathering stability. PVC is resistant to aggressive environmental factor, therefore the material of choice for roofing. And next one is fire protection. So it is a material resistant to ignition due to its chlorine content. Next, longevity. PVT products can be last up to 100 years and even more. And hygiene. It is a material of choice for medical applications, particularly bread and plasma storage containers. So PVC materials are used to store bread and plasma storage containers. Next, coming to the applications. So usually we know that, as I told you, there are two types of PVCs, that is rigid PVC and flexible PVC. So let us see the applications of rigid and flexible PVCs. So first, rigid PVC, it exhibits high surface strength and very good rigidity. It is used mainly for pipes, windows. Next one is plasticized PVC. It is used in manufacturing of films, expanded products, sheets, jacketing for electrical cables, etc. In building and construction field, PVC windows and doors, frames, shutters and panels, pipes for drinking water and distribution, and flooring. In packaging field, especially PVC used in foodstuffs to pack foodstuffs and pharmaceuticals. In cars, panels for car doors, dashboards, electrical cabinets, and matting. In field of electricity and electronics, jacketing of electrical cables for domestic use, insulation on electrical cables, telephones, and sockets. Next, some physical properties of the PVC. The physical properties of PVC is designated as rigid and flexible types. And first one is the density of PVC is 1.3 to 1.5 grams per centimeter cube for rigid PVC and 1.1 to 1.35 grams per centimeter cube for flexible PVC. And thermal conductivity, that is 0.14 to 0.25 for rigid PVC and 0.14 to 0.17 for flexible PVC. Yield strength 4500 to 8700 psi for rigid PVC and 450 to 3600 for flexible PVC. And next one is Young's modulus, that is 4,90,000 psi for rigid type. and flexible strength, that is 10,500 psi for rigid type, compression strength 9,500 psi for rigid type, and coefficient of thermal expansion, and that is the 5 into 10 to the power minus 5. Resistivity 10 to the power 16 ohms for rigid type, and 10 to the power 12 to 10 to the power 15 for ohms for flexible type of PVC. These are some important physical properties of the PVC. Next, some mechanical properties. PVC has high hardness and mechanical properties. The mechanical properties enhance with the molecular weight increasing but decreasing with the temperature increasing. The elastic modules can reach to 1500 to 3000 MPa. The soft PVC, that is flexible PVC, elastic is 1.5 to 15 MPa. However, elongation at break is up to 200 to 450 degrees 450. Friction is ordinary. The static friction factor is 0.14 to 0.5. The dynamic friction factor is 0.23. And this is the creep modulus and abrasion resistance. So the modulus or stress strain relationship must be considered in context of later duration of loading under the temperature, and abrasion resistance. Plastic generally shows excellent performance under abrasive conditions. And some thermal properties of PVC. The heat stability of PVC is very poor when the temperature reaches up to 140 degrees centigrade. PVC starts to decompose. The melting temperature is 160 degrees centigrade. The linear expansion coefficient of PVC is small and has frame retardancy. The oxidation index is up to 45 or more. Therefore, the addition of a heat stabilizer during the process is necessary in order to ensure the product properties. Electrical properties. So it is a polymer with good insulation properties, but because of its higher polar nature, in electrical insulating property is inferior to non-polar polymers such as polyethylene and polypropylene. As the dielectrical constant, dielectrical loss, tangent value, and volume of resistivity are high. The corona resistance is not very good. So it is generally suitable for medium or low voltage and low frequency insulation materials. These are some products of PVC. Pipes, sheets, and some plasters. So some advanced applications of PVC, that is unplasticized polyvinyl chloride, that is UPVC. Common name is UPVC for construction. So UPVC is used in the field of construction to flooring, as a flooring, as a pipes, covering and cables and different types of indoor frames, weather boarding and sliding and many more. These are very advanced applications of polyvinyl chloride. So this is a, we can call it is PVC house. So every material to construct it, this house is made up of PVC. So every item in this house. So very advanced application we can see here in abroad countries. Look at this. So this is a veneer house, polyvinyl house. So let us see how PVC we can apply in flooring. So flexible PVC type is used in flooring and it is a inexpensive and used in a variety of buildings covering the home, hospitals, offices, schools and etc. The complex and 3D designs are possible due to the prints that can be created, which are then protected by clear wear layer. A middle veneer foam layer also gives a comfortable and safe feel. The smooth and tough surface of the upper wear layer prevents the buildup of dirt, which prevents microbes from breeding in areas that needs to be kept sterile, such as hospitals and clinics. So what is the benefits of PVC flooring? Durability is very high, freedom of aesthetic effects available in a wide range of colors and patterns, and very ease of installation and very easy to clean and easily recyclable and variable thickness. These are the major benefits of PVC to use as a flooring material. So these are the different types of different areas of PVC flooring. And pipes. PVC pipes have been in use for over 60 years when compared with traditional pipe materials. PVC offers valuable energy saving during production, low cost distribution, and safe maintenance free lifetime of service. PVC pipes will not degrade to damage the environment and suffer fewer breaks or leaks than other alternatives. PVC is widely specified for pipeline systems for water, waste, and drainage due to its a theoretical service life of hundreds of years for buried pipes. PVC pipes suffer no buildup, pitting, scarring, or corrosion and provides smooth surfaces, reducing energy requirements for pumping. These are different types of PVC pipes. Next, coming to the another application of PVC, that is covering. So PVC is also used as coverings like the sheds in railway platforms, air-based sheds, nurseries, and etc. So this is very cost effective as compared to traditional tin shed, when are very heavy and have heat absorbent nature. So these are different types of sheets which are made up of PVC. So this is a nursery and this is the railway platforms and some stadiums. So these are also some PVC structures. So applications of PVC in London Olympics. So these are tensile fabric structures, cables and pipes, high performance sports surfaces and sheeting. A very large amount of PVC has been used, especially in temporary structures, has been recycled. And coming to the advantages of PVC. So it is a lighter in weight as compared to traditional materials like copper, wood and tin, etc. And it is easily available and producible, heat resistant and do not conduct electricity, can be casted to any shape, can be recycled and reused, and PVC can be easily shifted from one place to another. These are the major advantages of PVC. And coming to the disadvantages of PVC, it is not recommended for use above 340 degrees centigrade Kelvin temperature, although it can be taken into 353 Kelvin for short periods. And it is very sensitive to UV and oxidative degradation. And during preparation of PVC, HCl is evolved when it is decomposed. Its production causes some hazardous nature to the environment and some environmental effect due to the use of PVC. A discussion of some of the scientific issues concerning the use of PVC by the Commonwealth Scientific and Industrial Research Organization CSIRO in Australia included 2000. That PVC is building and construction applications has no more effect on the environment that its alternatives. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.